Today we are going to review exponent rules. The first exponent rule that we're reviewing is negative exponents. For example, if I have a to the negative n, that can be rewritten as 1 over a to the positive n. Or vice versa, if I have 1 over a to the negative n, to get that negative n out of the denominator, I can simply rewrite it as a to the positive n. Now looking at two examples with respect to numbers, the first example has 2 to the negative 3. That is the same thing as 1 over 2 to the third. Or the second example, 1 over 4 to the negative 3 equals 4 to the positive third. Now let's try some. Take a minute, pause the video, and try these on your own. The first one, rewrite the following monomials with only positive exponents. 2 to the negative 5th is the same thing as 1 over 2 to the positive 5th. Number 2, 1 over 7 to the negative 1. It's the same thing as 7 to the positive 1, or more simply, just 7. X to the negative 4th is equal to 1 over x to the 4th. And 1 over y to the negative 8th is equal to y to the positive 8th. Our next rule is product of powers. We probably have been taught when we're multiplying things with the same bases, all we simply do is keep the base the same and add their exponents. So these examples that are already done for you, 4 squared times 4 to the 9th is simply 4 to the 2 plus 9, which is 4 to the 11th. We can also do it with variables. B cubed times b to the 5th is the same thing as b to the 8th. Take a minute, pause the video, try these on your own. Even though here we have 3 terms, it's exactly the same thing. I'm multiplying all these terms together. For number 1, they all have a base of 4. So I keep the base of 4, and I simply add all my exponents together. So I would end up with 4 to the 0 power. Anything to the 0 power is simply just 1. The second one, they're multiplying all my terms together. They all have a base of x. So I will simply add my exponents together, which gives me x to the 9th. Our next rule is quotient of powers. When I have the same bases and I'm dividing, all I do is keep the base the same, but I subtract my exponents. Okay? So the first one, 5/3 divided by 5 is really 5 to the 3 minus 1, which is 5/2. The next one, x to the 7th divided by x to the 3rd, is really x to the 7th minus 3, which is x to the 4th. Take a minute, try these on your own. Now, simplify, write my answer using only positive exponents. So for the first one, x squared divided by x cubed is x to the 2 minus 3, which is x to the negative 1, which is really 1 over x to the first, or just 1 over x. The second one, we can actually reduce our coefficients. So I can think about reducing my coefficients, so I just get 2 in my numerator. And then I can subtract my exponents with the base of x. So I end up with 2x to the 6th. Nothing is in my denominator in this problem because I have no negative exponents. The The next two rules are power of a power and power of a product. The first one is if I have some base being raised to an exponent and that whole quantity is being raised to an exponent, then what I do is I simply multiply my two exponents together. And in that example, I have a squared to the fifth. That just equals a to the 10th, okay, because obviously 2 times 5 equals 10. Power of a product is when I have two things in my parentheses, and they're both being raised to some exponent. Then what I do is I almost distribute that exponent to each term within my parentheses. So in the example xy to the third, it's really equal to x cubed y cubed. Here's two examples for you to try. So the first one, a cubed to the sixth, really just becomes a to the third times 6, so I get a to the 18th. The second one, negative 2 p cubed s squared raised to the fifth. Basically, each number gets the exponent raised to the fifth. Okay. Negative 2 to the fifth is negative 32. And then I have p to the third to the fifth, so I apply the problem that we did in part 1, so that just becomes p to the 15th. Then I have s squared to the fifth, which is really just s to the 10th. So this was applying both parts. The last rule we're going to look at is power of a quotient. If I have a divided by b and a and b are both numbers and that whole quantity is being raised to an exponent, I can simply think about it as being a to the n divided by b to the n. An example of that is right here. If I have x over y to the fourth, that really is the same thing as x to the fourth over y to the fourth. Another way to use the power of the quotient is if I have a over b being raised to the negative exponent. Negative exponents are very hard to work with, so force it to become a positive exponent. We do that by taking the reciprocal of whatever's being raised to the exponent. Then we can apply the previous rule that we just talked about. So in the second example, I have x over y raised to the negative 6. I don't want to deal with this negative 6, so I take the reciprocal, and it becomes y over x to the positive 6, which is really just y to the 6 over x to the 6. Try these two on your own. The first one we get is negative 3 to the fourth, x to the fourth over y to the fourth. Negative 3 to the fourth is 81, x to the fourth, y to the fourth. The next one has a negative exponent, so I'm simply going to find the reciprocal of the part that's being raised to the exponent, so then the exponent becomes positive. Now I can apply the previous rule, and I get 4 to the third over a to the third, which gives me 64 over a to the third. Now let's put it all together. Pause it and try these two on your own. For number 1, there are a couple approaches for either of these problems, but what I'm going to do, I think it's more simple to simplify whatever's in our parentheses first, and then once that's as simple as possible, then raise it to the fourth. So in the first one, I have x in my numerator and my denominator, so I can subtract those exponents. So I simply get negative 2 x to the n over y to the third. All of that is still being raised to the fourth. Now, since I cannot simplify that any further, now I will simply raise everything to the fourth. So my final answer is 16 x to the 4n over y to the 12th. I apply the same rule with number 2. I'm going to first simplify everything that's inside my parentheses and then at the end raise it to the 5th. So I have the same bases in my numerator and my denominator, but be careful here when I subtract them, a to the 5y over a to the 6y, I get a to the negative y, so that should go in my denominator. So then I get negative 3 is the only thing in my numerator, a to the y, b to the 4th is what belongs in my denominator now. Now I can raise everything to the 5th. So negative 3 to the 5th over ay to the 5th, b to the 4th to the 5th. So then I get negative 243 over a to the 5y, b to the 20th. So we reviewed a ton of different examples with exponents, so hopefully this video helps.